Let's talk about hearing and the brain. The auditory pathways in the brain pass through the brainstem, the midbrain, into the cortex. The thalamus also plays an important role in auditory cognition. All of the auditory information passes through the thalamus on the way to the cortex. Brain imaging research has shown that it's in the right hemisphere that you have specialization for music processing. There are different areas in the right hemisphere for listening to bursts of noise versus listening to melodies versus comparing pitches of different sounds. Brain imaging studies also show that it's the left hemisphere that specializes in the perception of speech. So here you see the areas of the left hemisphere involved in listening to bursts of noise versus listening to words versus discriminating speech sounds. Information about sound that is received by each ear is transmitted to both hemispheres, but it turns out that the contralateral pathway is stronger, meaning that information from the left ear is more strongly conveyed to the right hemisphere than the left hemisphere, and information from the right ear is more strongly conveyed to the left hemisphere than the right hemisphere. Have you ever noticed when people are using the cell phone and holding it up to their ear, you find that most of the time people are holding the phone to the right ear? Laboratory studies have confirmed that there's a right ear advantage for listening to language, meaning that you process it better, more accurately, and faster than the same information if it were processed by the left ear. Laboratory studies also show that the left ear has an advantage for listening to music or speech that has emotional content, like tone of voice. Someone has a very angry tone or a very sad tone. We're better at detecting that if we're listening with the left ear. The dorsal and ventral pathways in the auditory cortex are specialized to process information about different aspects of the sound. The ventral area, shown in green, is involved in identifying what the sound is, and the dorsal area, identified in red, is involved in identifying where the sound is. Damage to the ventral pathway can leave one with auditory agnosia. One can hear fine, but just can't recognize what one is hearing. Children who have lots of ear infections in childhood might develop auditory processing disorder, which is similar to auditory agnosia. They can hear fine, but they have difficulty perceiving the speech sounds. This might affect as many as 5% of school-age children. Brain damage to the right hemisphere can also lead to amusia, which is the inability to recognize musical tones or to reproduce them. Some individuals get no pleasure listening to music. It just doesn't do anything for them. They don't have brain damage, they've just always been this way. The condition is called musical anhedonia. Some individuals have synesthesia, which is a very rare syndrome in which people have complex sensory experiences involving a blending of the senses, such as being able to hear colors or seeing colors when you hear music or other sounds. Music therapy has been known to be useful to those with mood disorders such as depression. Music is also beneficial to patients who've had stroke or who have Parkinson's disease. If they move to music, they can actually improve their motor functioning. Music therapy can be beneficial for patients with dementia. The recent documentary, Alive Inside, shows some remarkable footage of dementia patients who are completely incommunicative, but after listening to music can carry out full conversations as though they were much healthier than they were. That's all for now.